Hello. In this video, we'll be looking at networking protocols. First off, what are protocols? Protocols are simply rules that govern how we do things. So let's look at, for instance, fire truck. What if a fire truck is pulling up behind you on the interstate? What do? You slow down, you pull over to the side, and you come to a stop, correct? Okay, so that's a protocol. It's a rule on what we do to allow for the emergency vehicles to pass us. Same thing within networking. We have to have rules on how we get information to go places, how we transmit information, how we receive information. Now, one of the oldest rules that we have that we still use for transmitting information is file transfer protocol. File transfer protocol, or FTP, allows for transmission information. It can be files, it can be music, it can be basically whatever you want to transmit. Now, with file transfer protocol, FTP, it uses two separate ports. First, we can see in this diagram, port 21 at the top of our screen. That's what it's using to establish the connection for us. So we're saying, hey, I need to make this connection. Once the connection is established, we switch to port 20. And port 20 is what we're actually going to do the communication through as we're transferring our files. Now, with these different ports that are being used, you have to be careful, because what if on your firewall you've blocked certain ports? Then you're not going to get through. If you've blocked port 20 and port 21, then FTP is not going to work. So be careful as you're setting up your rules or your firewall rules, what ports you block to allow different transmissions. Now, with FTP, FTP is unsecure, meaning that everything is plain text. So when I transmit my credentials on port 21 saying, hey, I need to connect to the server and transmit information to you, my username, my password is being transmitted in plain text. So anybody with a packet sniffer can go through and pull out those credentials. Same thing, when I start transferring information back and forth on port 20, my information is being transmitted in plain text, so everybody who sees it, or everybody who knows how to sniff the information with the tools, here again, such as Wireshark, they can see my information and then have it to manipulate. So we need to look at what we can do to secure that information, for not everybody's going to see it. But we're going to look at that here in just a few minutes. First off, how do we actually establish a connection for FTP? There are multiple ways that we can do this. One of the ways, and probably one of the older ways, is using a terminal window. You could also use a command window if you're a Windows fan. Now, with terminal, what we're establishing here, we're connecting to, we can see the top red box, we're connecting to FTP client, and the IP address is 192.168.1.7. Once we actually make the connection, it's going to ask us for our credentials, our username and our password. We type that in and we hit send. If it accepts it, we can see now we have an FTP prompt, and so we're good to start typing our commands for what information we want to transfer. Now, what if you're not a fan of terminal windows or command lines? Now, there's a way for you to do that also. We can use a GUI interface. So there's multiple different interfaces you can download. Just depends on what you like and what you feel is going to work good for you. Now, at this one here, we can see multiple things going on. We've connected to our IP address, and we can see that we're connected on port 21. Now, from there, very simple, drag and drop, just like you would on your normal computer. Drag the files over to the server that you want to upload. Drag the files from the server to your local client that you want to download. Here at the bottom of the screen, we can see a progress meter. We can see which files are downloading, how close we are to getting done with them, what files are queued to be uploaded or downloaded. So that way we can kind of keep a track on what's going on there. Now, I'd already told you about Wireshark and different packet capture tools. Now, here's a screenshot of Wireshark. May not look like much to you if you don't know what's going on, but we can see the source address, where the information is coming from, the destination, where information is being sent to. We can see some information on the right-hand side, but if you know how to drill through this, this is where I would go to pull out your username and password and what information you're transmitting through FTP. So this is why I said you need to be careful in using just plain FTP, because it's unsecure. So what can we do to secure that? We can look at layering on different protection. So we have FTPS, File Transfer Protocol Secure. We have SFTP, Secure File Transfer Protocol. And so let's take a look at those here for just a few seconds. Now, with FTPS, File Transfer Protocol Secure, it relies on SSL. Now, with SSL, we're actually layering two different things together. So when we use two things instead of one thing, it can cause some issues, right? So we've got to be careful about this. With SSL, we're not actually secure until the transmission is established. So we can see here over in diagram 1 or picture 1, we're going up, we're asking for a connection, we're going up and over to where we have our web host in item number 4, and we're trying to establish that connection. Once we actually establish that connection on line 5, then we can see on line 6, we're actually secure with the information that we're transmitting back and forth. But there's still that initial unsecure connection that we're making. So you want to be careful about that and decide, is this going to work for you or is this not going to work for you? I would encourage you to try to find a protocol that uses just a single protocol instead of 2 protocols that are layered together. Now, I mentioned SSL. I don't think I told you what SSL is, but Secure Socket Layer is what SSL stands for. You might also see TLS, which is Transport Layer Security. So just some terms that you want to be sure you're familiar with. SSL, Secure Socket Layer, and TLS, Transport Layer Security. Now, I mentioned this one uses 2 separate protocols for our transmission. If we can find one protocol that does everything together, then we're better off. That's where SFTP, Secure File Transfer Protocol, comes into play. SFTP was designed as a suite or as a package. Said suite, actually FTPS is a suite because it's 2 connected. SFTP, Secure File Transfer Protocol, is its own new protocol that it relies on for security. So we're transmitting everything secure with this. So it'll be a better transmission if we can do it. Now, we're in our picture here, we can see we're at the hotel. We're needing to transmit information to our home office. So we're using SFTP to establish that secure transmission and to transmit our information. So a little bit better route than using FTP or FTPS. Okay. Now, that's for file transfer and file transfer protocol. The next one we want to look at is TCPIP, Transmission Control Protocol and Internet Protocol. Now, TCPIP is actually a suite of connections for us. Now, what we'll be looking at is what you saw there for just a second, and I'll bring it back, is the OSI model we had on the left-hand side, but then TCPIP has its own model, which was on the right side, and we'll go back and look at that in just a second. But here again, we have a suite of protocols. TCP, Transmission Control Protocol. IP, Internet Protocol. Now think about what we're saying there. TCP, Transmission Control Protocol. So we have that word transmission in there, right? So let that be a clue to you on what we're trying to do. We're trying to transmit information. We're dealing with transmission. Internet Protocol is dealing with the internet and how we're actually getting it to go across the internet and establish those different connections. Now with TCP, if you remember back to our OSI model, I guess let me go ahead and bring that back up. With our OSI model over here on the left-hand side, TCP, Transmission Control Protocol, we're looking at layer 4. So if you're looking at layer 4, that's the transport layer, right? Now with IP, it's layer 3. So we're looking at the network layer, okay? And if you look at the TCP model, the TCP/IP model over on the right-hand side, we can see the internet layer and the network layer line up with each other, and we can see that the transport layer and on the TCP/IP side and the transport layer on the OSI side do line up. Now, with these 2 different models, if these look foreign to you, I encourage you need to memorize these. For the OSI model on your left-hand side, you have physical, data link, network, transport, session, presentation, application. Find a way to remember it. For me, I remember it as please do not throw sausage pizza away. That's an acronym, but that's what I use. Please do not throw sausage pizza away. And that's how I memorize it, and that's how I remember it even if I'm in class. There are times where I'll have to kind of say that in my head in order to get that information out. So as far as the right-hand side with the TCP/IP model, you have your host, then you have your internet, transport, and application. So you do want to take some time to look through these and be sure you have a good memory on what's going on with these. Now, with our next thing that I want to talk about is I want to talk about simple network management protocol, and I also want to talk about internet control message protocol. Now with both of these, what we're looking at is how we're transmitting information on our network. Now with SNMP, Simple Network Management Protocol, and then we also have ICMP, I'm sorry, I'm getting tongue twisted, Internet Control Message Protocol. These work together as far as transmitting information and as far as how we connect to different devices on our computer or connect different network segments together. Now, with these can also be used for trying to find information out about the network. Let's say you're trying to break into a network or hack into a network. These can also help out with that. So you got to be careful on what you allow and what you don't allow to go through on your network. Now, let's take a look at ICMP, Internet Control Message Protocol. Now with this, we can have a couple of different things. First off, it's a great tool when we're trying to troubleshoot our network. It's a protocol on how we transmit information. So we can go in, we can do a ping. Most of y'all should have heard about a ping by now. We can ping information on our network to be sure we're getting connections established and that we're getting results back. Now that could also be a bad thing because, not only a good thing, but also a bad thing because the bad guy might actually see that information to see which IPs actually are valid and what are working, what's connected to those devices. So we can do an informational query or a query message such as with those pings. Also we can get error messages back. When we do a ping, we see how long it's taken for that transmission to happen. Did we actually establish that connection? So we can see we can get some good information back from it, but also some bad information can happen from it. Some of the bad information that could happen from it, we could look at network discovery, find out what's on the network, what's moving around, where it is on the network. Smurf attacks, where we're actually trying to spoof the IP address and make it think that it's going somewhere else, or maybe make the computer think that we're actually talking to another computer. That also flows into a redirect attack, whereas if we're redirecting information to make it think that it's going to one location, but it's really going where we want it to capture it and do what we want with it. Ping of death, we can crash the network that way, just overwhelm the network by pinging it so much. So those could be some good reasons to block ICMP traffic, but you have to decide as a network technician and as a network admin, are the advantages of blocking it to protect your network worth what you're going to lose as far as diagnosing what's going on your network. Now here again, you could always temporarily turn those back on if you needed to. Now with Simple Network Message Protocol, or SNMP, this is what we're looking at when we're trying to establish remote connections. Here again, are you going to allow remote connections? We have servers in this building here. We have servers in a different building across our facility. Do we want to physically have to walk across the campus to get to that other server and work on it? What if you're remotely located and you have an office here in this town and your next office is, let's say, in Dallas? The time to drive to Dallas to connect and fix the server, is it worth it for that technician? Probably not. Probably more cost effective is to allow remote connection in to do some server maintenance or upgrades. And so you have to decide on that, and are you going to allow that traffic? So some just different decisions you have to make as a network technician. Now, the last thing that I want to look at in this video is DNS, Domain Name System. Now, without DNS, how are you going to communicate? Think about your address, or the address for the college here, bpcc.edu. Easy enough to remember, right? Google.com, Netflix. What are some of these other IP addresses or DNS names that you know that we use in everyday life? Do you really want to have to remember an IP address? 127.101.14.1. Do you want to have to type that in? Probably not. You want to remember Google.com. You want to remember Netflix.com. And so that's what DNS helps us out with. With DNS, what we're looking at is how we're actually finding out what's what. Now, the computer as itself doesn't care that we're typing in google.com. It needs that IP address. So that's where DNS comes into play. We type in google.com on our computer, and it goes through DNS to look and see, hey, what is this google.com address? And it actually goes out and finds the IP address for us. So it's going to go from our computer to our DNS client that we have locally. Hey, do you know who this is? Yes, I do. Here's the actual IP address, and return it to our computer. If it doesn't know it, then it's going to go basically out to the next DNS server. It's a layer of trees, let's say, different layers that it's going to go out and keep on asking further and further up this layer list until it actually finds out who knows who google.com is. Once they find out who Google is, then it relays it back down that chain until it gets back to our computer so we can actually get to our website that we want to look at. Let me zoom in on this screen just a little bit so you can have a better chance to look at it and see what's going on with it. We can see in layer 1, your computer asks your router for the DNS record. Your router asks for the ISP, the Internet Service Provider, for the DNS record. And you can see it just kind of goes up that chain until it actually finds it, and then it can return that information back down to you. Okay. Now, with DNS, DNS is not always truthful to us. There can be what we call DNS poisoning. With DNS poisoning, what's happening is we can make the computer think it's going one place, but it's not. So what if somebody sends in some fake information? I can make your computer think you type in google.com and it may take you to disney.com. And so by doing that, I've poisoned your DNS cache. So there are times you may have to actually clean your cache up. If you have a roommate, you could have some fun with them, do some research and find some videos on how to adjust your host tables on your computer, and you can reroute it. So that way when they do to go try to type in google.com, it takes them to Disney or whatever website you choose. You simply have to look up the IP address of Disney and input that and associate it with Google. And now when you type in Google, it's going to take you to Disney instead. So you can have some fun with that, freak out your roommate with you on that a little bit if you wanted to. So now that's what I wanted to talk about in this video. I hope that you found out a little bit more about protocols and how those are rule sets that govern how we transfer information through our devices. So until next time, have a good day.